Can I continue my presentation?
Yep.
All right.
Should be fine now.
Okay, great. Great. Thank you so much to our host, and I apologize for all the inconveniences, technicalities, and whatnot. So today, Ahmad Alif Kamal, will be presenting directly from Malaysia over here on my work and project, which is Analytic Hierarchy Process weighted logistic regression models for the League of Legends. So this product has been supervised by the Associate Professor Dr. Muhammad Ashraf Mansoor, as well as Associate Professor Dr. Muhammad Sharidan Muhammad Kasimuddin, both from Universiti Sains Malaysia, Malaysia. Right, so esports such as League of Legends are rapidly becoming more than competitive environment, and there are active laboratories where future forms of digital teamwork strategy education as well as online culture constantly being tested, constantly being evolved for the sake of academic studies all around the globe. And there has been a lot of resurgence on various fields of using the data from esports, especially mobile-based game, multiplayer online battle arena, for the sake of mathematical and operational research-based studies. So with millions of matches played every day, we have a lot. And by I mean, when I say a lot, it is a very various valuable data available over at the internet at our expenses, and it can be used for a lot of things like decision making under pressure, communication, technology, as well as coordinated movement in very controlled environments. So predicting match outcomes from this data is not only useful for coaches and analysts, but it's also helping researchers out there to understand a lot of the inklings and happenings within the game, and then to be translated into human and also layman language for a lot of readers out there to understand what gaming is all about and how it can benefit human from a lot of perspective. So many existing prediction tools focuses on raw numbers. This is what has been going on a lot in different published works. And experienced players as well as coaches know that deeper strategy controlling space, uh, vision as well as tempo actually matters equally, if not more, as compared to only the numbers, the KDAs, the GPM, the XPMs, and so on. So by taking that perspective of these experts, we can say that we would like to propose a research question on how can expert knowledge about League of Legends strategy be integrated into something like a mathematical predictive modeling so that we can clarify and truly see what's actually driving a team towards winning the match or competitive success. And we like to see how to combine expert gaming knowledge with computer-based prediction in understanding what drives competitive success. One key goal that is to go beyond who is ahead right now and learn why a team is on track to win, although it seems that they are losing. We would like to investigate whether early decisions such as securing objectives or controlling vision can be turned into a simple but understandable score that reveals which team is actually building a sustainable advantage over time. So without further ado, we will go straight to the method of our study. Now, from within our methods of study, we decompose it into different subsections. One is a data set. So we studied a high-level League of Legends matches from the Diamond skill tier, focusing on the first 10 minutes of gameplay, where the period strategies often take shape, but the outcome is still far and not yet decided. So this is an example of how does the dataset from the publicly available kaggle.com can be downloaded and be used for a lot of various projects and studies. Next, we have a decision-making tool called the Analytic Hierarchy Process. Now, this is a very comprehensive and systematic tool where we can use human insights, human judgments to be converted into numbers or quantitative values, and then it will produce numbers that represent something, and that particular something I will explain a little bit later. So to make sense of our complex data, and we would like to study more from the dataset that has been downloaded in the previous slide, we change or we use what has been published by Junior et al. In the 2020 project, where the roles or position and the skill set can be connected as a simple hierarchy tree diagram from the Analytic Hierarchy Process, or the AHP. So the first layer of the after the goal, jungle, top, mid, bot, ADC, and support is the position, and then even lower layer is the skill set of the players in the team: combat, farming, objective control, survivability, and vision. So combat means who wins fight and contributes more firepower. Farming means that who gathers resources such as gold and also levels and experience. Objective control means that taking main objective and also the secondary objective from within the game to gain more advantage over time. Survivability means that who actually avoid risky deaths and be able to live longer and have lesser death counter compared to his teammate. And last but not least is vision, who sees the map more and who actually denies the opposing team or the enemy of information. So AHP is basically a multi-criteria decision-making tool where we will get human experts to involve with us, and then they help us by comparing between criteria or sub-criteria as shown in the previous tree diagram quantitatively. So it will enable us to calculate the final form, which is called a priority vector, which means the relative importance of certain criteria over the others. And the values of this importance is only between 0 and 1, but the total relative importance will definitely sum to 1 only. This is an example of how the experts involved, which is trying to compare. The first here is trying to compare between combat or team fighting versus vision. That is a word observer word in the game of League of Legends. So say that for the expert that these two component or sub-criteria is of equal importance, they will provide the number 1, which means both combat and also vision is equally preferred or equally important. Now, for the second row, we see that it is the comparison between combat and farming. Okay, so for the expert, say that the example here, expert prefer combat to be much more preferred, much more important from a single phase of time compared to farming. So the expert will provide, or we input the value of 5, means that combat is much more important than farming when a person or a player need to compare between these two subcriteria. Now, the comparison only exists as a pairwise, means that we only let the expert to compare 2 components at a time. There will not be a comparison between more than 2, which is 3 components or 4 components at a time. So it can only be between 2 components. By the end of the comparison, the AHP will help to calculate and come up with these numbers. So to make it easier for our viewers, the number is converted into percentage, where we can see over here that, for example, the first layer after the goal, jungle, top, mid, bot, and support. Jungle over here consists of 51.9% compared to, say, mid 2.49%. What does this mean is jungler will have more priority, more preference, more important in terms of favor drafting compared to the mid laner. This is what we have obtained from the experts. And in terms of the skill set on the second layer of the bottom row here, combat is 19.01% compared to objective control, which is 29.17%, mean that in every phase of the game, objective control is much more important compared to the other sub-criteria. And as we can see, farming has the lowest priority, which is the 15.58%. So these values from the AHP tool has been published by Junior et al. In 2020 paper of the Journal of IT Asia. So next we will have in our methodology, which is a logistic regression. Now, logistic regression is basically a machine learning tool used for prediction, where we see that over here in the figure on the left side, the most common a way to make a predictive analysis is by using a linear model consisting of y equals to b naught plus b1x. But for logistic regression, a transformation tool called a sigmoid function, which over here is written as p equals to 1 divided by 1 plus exponent of negative b naught plus b1x, is basically transforming the linear line into a non-linear line over here, which represent where if we put certain value inside this equation, you will either get less than 0.5 or more than 0.5. And if it is more than 0.5, our model, where our equation will output or represent to us that it is predicted as a win for the team. And if it's less than 0.5, it's going to be predicted as a loss. So we will be using the data that we obtained from Kaggle in the CSV or Excel file shown before, and then input them into these particular equations. And we have over here add different type of variants with different capabilities just to see how does it perform to predict whether a team wins or loss in the sense of using the data in the Excel. So to actually measure whether our model is good or not so good, so we tested it using a standard performance metrics in the machine learning study consisting of accuracy, precision, recall, F1 score, as well as ablation study. So accuracy means that how often that the model is correct. When the model input all these values and then it produces a win as a prediction, compare it back to the Excel and the CSV file we have shown before, whether it is truly labeled as a win or as a loss. If it is correct, then it contributes to an increase in accuracy for our mathematical model. Precision means that when the model predicts a blue team win, how often is it correct? That is basically saying how true is the positive answer. Recall over here means that how many actually blue team wins the model successfully identify. So sometimes that the model is very accurate, but it is predicting on the loss rather than the win. So we need to actually see how much that it is predicting the winning instead. And the F1 score over is basically a balance or a mean balance between precision and recall in terms of ratio. Whereas ablation study means that what happens if we remove something from the equation, because the equation will consist of data such as XPM, GPM, KDA, number of controls from the Baron, number of obtained heralds, number of tower push, number of farms performed, and number of so many other things that has been captured by the Excel format before. So what happened if we remove certain thing from that particular calculation of our prediction? So in short, this is the flowchart of how our study is conducted. We are going to use the data from AHP published by Junior et al. As well as the dataset from the Kaggle.com, consisting of 10 minutes of in-game statistic from Diamond Rank Mesh only. Put it inside the logistic regression of 8 different type of model variants, optimize them, and then see the performance of the model. So the result that we obtain is across all 8 logistic regression model variants, the integration of the AHP weights substantially improve predictive accuracy and interpretability. Usually what happened in the previous study, they only use the data set and the logistic regression model. They do not have any other components in trying to predict a win. So they simply use whichever team has a higher GPM, higher XPM within the 10 minutes of the game. So it is very highly likely for the team to win. But by incorporating AHP, where we say that we wanted a human-based judgment to be incorporated into model, because sometimes during the first 10 minutes, we cannot really see whether a team actually can win or whether the team is in a definite loss state. So that's why by incorporating the AHP, where the humans say that actually vision control is much more important, actually that the team that has more objective control has a higher tendency to win. So we want to have this human judgment to be incorporated into the mathematical equations that we use. So therefore, from out of all the 8 model variants, we see that we have the ensemble and also hierarchical type or base variance model to consistently achieve the best performance. this is basically saying that only by using the first 10 minutes of data, our ensemble and hierarchical type can predict up to 74% and 73% respectively on seeing which team is actually won in the end using only the first 10 minutes of the data. Now that is interesting because we are trying to predict the future. So this model maintained a balanced trade-offs across accuracy, precision, as well as recall, but showing that they not only predicted winners correctly, but they can also minimize a false positive or false negative. False positive means that wrongly predict which team won, and false negative mean wrongly predict who is actually lose. The baseline and the standard regularized logistic regression model, which is the most commonly used in a different League of Legend based study or even Dota based study, can be seen that they perform nearly as well, but not as good as the ensemble and hierarchy model that we use, confirming that AHP weighted feature actually strengthen even the simple model structure or the basic model structure, whereby the model with interaction term as well as time series features has been seen to be underperformed, suggesting that early game data lacks the temporal variation needed, means that it's lacking in terms of the timing effect needed to make the lag-based model more meaningful. So only these two that has been related with time-based data is shown to be subpar or underperformed. So in essence, the ensemble models think like a team. So it aggregates multiple perspectives, just as human coaches might pull insights from analysts and different type of stakeholders, specializing in different aspect of play to actually make the end prediction. So it is almost resembling a human-based judgment. LR models that combine multiple perspectives like a coaching team reviewing gameplay together with a different stakeholder actually perform the best, and then most importantly, including the expert-based score, lead to a noticeably better prediction than just simply using the dataset, the values, the Excel and the equation only. So from our study, we can actually deduce that AHP can help us to bridge human expertise as well as machine learning, because machine learning is purely data driven and it's only between data and computer. So by actually incorporating AHP into it, we can see that our framework will perform much better, and it is easier to be translated into human language. It is much easier to be interpreted. Okay, because the model's prediction is explainable and it's aligned with how professional teams such as the coaches, the analysts think. So we can move one step further beyond the black box of AI towards the more interpretable analytics. So if anyone out there who is actually in machine learning based study or practitioners, they can understand that by putting this data into the mathematical equations only, we actually are lacking in terms of the interpretation and explanation. That has always been the challenges and the big hurdle in artificial intelligence generally based studies. So again, from our study as well, you can see that objective control and vision are actually good strategy predictors. And then by actually having seen this one, the teams that secure early dragons, early towers, early heralds can accumulate exponential map pressure and tempo advantage, where we can clearly see what we usually call as snowballing, but in terms of numbers. So now by using this framework, we can actually understand the concept of snowballing and comeback through the mathematical and empirical evidence even better. Okay, because a lot of these components are actually being said by the analysts, being said by the casters, but we don't actually see a concrete or empirical evidence to represent it. Okay. So in terms of implication for coaching and as well as a digital transformation, our model do more than just predict. They can actually help us to teach what is decision making. Because for coaches, for example, AHP-based weighting clarifies which area to prioritize when developing early game snowballing strategies, as well as how to gain more momentum as the time phase increases. But for broadcasters or for analysts and hostess as well, the team advantage score can enhance the storytelling, giving audiences and the general viewer, gamers out there, an even more accessible, grounded based explanation based on the real data use. So last but not least, we can see that eSport can actually be used as a global laboratory because our framework embodies what this particular conference theme of future realities as using eSport as a global lab directly means. We combine mathematical structure, we use expert knowledge, and then we see the live behavioral data where esports can actually become a really really nice test bed for a lot of digital collaboration as well as adaptive intelligence. In this way, we see that League of Legends, one of it, there's more over out there. I mean, the data as well as the game and even more genre out there in esports can become a very good global testing ground so that we can see how human can actually impact the technology using interpretation and very complex judgment and decision making to collect more and more hard, concrete, empirical evidence for future realities laboratory. And that is all for my presentation today. I thank everyone for listening up until now, and then hope you enjoy more for the conference. Thank you.
Hold on, I'll speak.
Okay, all right. Yes, I can actually see one. Yeah, one question from Yuizon. So regarding current partner endeavors already implemented by Riot Games such as Coinbase and I think more. I think maybe Mobility is one as well. Are there any considerations on any implication that may be relevant to those kind of stakeholders? Now, the most impressive things about artificial intelligence based studies is we can have no one solution that can be used for um, generally for almost every cases of studies out there. Means to say that there will always be a development of new things over time, so that they can be used for hopefully for a much more better generalizability kind of case studies. So in terms of, for example, Mobalytics is an inventory base for data collection in in-game feature that uh, highlighted the statistic from within a gameplay by casual player, lower rank players up until the professional player where people can study. But something like Coinbase and so on, it might be more maybe more betting related or transaction wise. So it will require a different landscape or different background of knowledge and study to be incorporated over there. So it will be depending on the stakeholders themselves. If the stakeholder really provide more funding or more support for their advantage towards their implementation of partner-based working with Riot Games, as for example. So they might need to consider that what can they gain from that particular model output. or what they should get or what they should be focusing on using that artificial intelligence product towards achieving more benefit or more profit or providing more assistance to the players and so on. So it really depends. But usually it is based on these sorts of stakeholders that how the work will be moving about. Okay, you can actually really see that there are some really passionate esports enthusiasts that is working in academic as well as in industry themselves. Really rarely you can see that we are developing things that can change the landscape of what is already out there. But what we actually producing is actually mean a lot more towards the spoilers and also a very very technical industry players only. So for those people that has actually been working and partnering with Riot Games, conducting